Thank you, everyone, for being here. And we really have a distinguished set of panelists today, and no intros, but I decided to do a little bit of an intro just to give you a sense of, the kind of that panelists have. So have Professor Stuart Russell from UC Berkeley. He's a distinguished professor of computer science at the University of California at Berkeley. He's also a member of the National Academy of Engineering, a fellow of the Royal Society. He's got the HKI Research Excellence Award, a recipient of the HKI Computers and Thought Award, the ACM Allen Newell Award, etc. He also received the OBE from Her Majesty, and he's an honorary fellow of and fellow for AAA, ACM, AAAS. So, I mean, it's just endless. I can keep going for the entire duration of the panel. We're so lucky to have you here. Thank you for accepting our invitation. We have Professor Lily Bloom from CSIRO, Data 61, the Digital and AI Division of Australia's National Science Agency. And he's also a professor at UNSW, and he's a recognized leader in AI engineering and responsibility. And he represents Australia in the International AI Safety Science Report. And he contributes to OECD.ai on risks and accountability, ISO AI standards, Australia's AI safety standards and guidance. And so, really very, very lucky to have that perspective as well, of somebody who has contributed deeply to standards and how some of these things can be operationalized. Then we have Professor Somesh Shah from the University of Wisconsin. He's actually an alumnus of Delhi. So that's great to see. He did his PhD from CMU and went, and his focuses on security protocols of analysis, intrusion detection, and so on. And he's a fellow of the ACM, IEEE, and AAAS as well. And then we have Professor Nicholas Davis from the University of Technology, Sydney, Industry Professor of Emerging Technology at the UTS. And he co-leads the Human Technology Institute, which is a new initiative on Australia's capabilities, ethical and responsible AI. And so, welcome everyone to the panel, and we have 85 minutes for this panel, 80 more minutes, and into safe and trusted AI means, how it can be operationalized, what the greatest challenges are, and I would also like to touch upon, some of the local context as well, given we are, in India and the population and so on. So we'll get into all of those. So we started with really like panelists, and we can start maybe, from Professor Stuart. Safe and trusted AI. Since we are the research researchers, big research challenges that you actually see in this and in general that we should be focusing on.
So at the high level, it's pretty easy to say what safe and trusted AI means. It means AI that does not harm people, that is beneficial to them, and that we have strong reasons to believe that it is safe. So trust means knowledge of safety in some sense, that you have a good reason to believe it's going to be safe. Now, of course, the difficulty is what is safe and what does harm mean, right? And that has to do with an underlying concept that philosophers and economists have studied for centuries, which is this notion of preference. And I'll say very precisely, because we can be a little bit, this is a research symposium. A preference is a ranking over all possible futures of the universe, right? And a human being doesn't carry that ranking around in their heads explicitly. It's not a big long list that they have in their mind, because there's infinitely many futures of the universe. But the idea is that if you were given two futures, maybe I could even show you, movie A and movie B of of the future. Now, that would be an abstraction. It's not fully detailed, but you can look at those two movies and you can say, oh, I really like movie A. I don't want to be in movie B where, I die at 23 years old of some terrible disease. I want to be in this other movie. And if you're not sure, then you can say, okay, I need more detail in the middle section, and you can get more detail and so on. But that's the basic concept of preference, which is fundamental to thinking about what we want AI systems to do. Now, we are never going to be able to write that down. And this is something that we learned when we started trying to move AI systems out of the lab away from toy problems to real problems. So by a toy problem, I mean a situation where the preferences are sort of pre-specified. They come with the situation. So for example, in chess, you're trying to checkmate the opponent, right? And that's it. In Monopoly, you're trying to own the property and make the other players go bankrupt. But in the real world, it turns out to be extremely difficult to say what you want correctly. And we call this the King Midas problem. So King Midas said to the gods, instead of the AI systems, but let's pretend that they were AI systems, I want everything I touch to turn to gold. Sounds good. But then too late, he realizes that includes his water and his food and his family. And then he dies in misery and starvation. So this is the problem of misspecification. And if you create AI systems that are pursuing misspecified objectives, then you have what we call misalignment. The AI system is trying to achieve something, and in the process is actually in conflict with what you really want the future to be like. So we seem to be stuck, right? How do you get AI systems to do what you want, to be safe and beneficial for us, if you can't say what that means? And that has a solution. That the AI system knows that it doesn't know what that means. It knows that it wants to be beneficial to humans, to further our interests, but it knows that it doesn't know exactly what those interests are. And if you've ever tried to buy a birthday present for your significant other, you know exactly what the problem is, right? You want to buy the birthday present that's going to make them happy, but you don't know what it is. So what do? Well, you can ask questions, but then that spoils the surprise. You can ask a friend to ask your significant other what they want and then get it that way. You can leave hints around the house and see what they respond to. There's all kinds of tricks that we engage in. And so this is the situation that AI systems find themselves in. But it turns out that this is a solvable problem, right? That we can formulate this mathematically. We can create, we call it an assistance game. So it's an assistant is trying to be helpful to us. And it's a game because there's really multiple entities involved. There's the AI system and the human. The human in this game has an incentive to be helpful to the AI, all right, explaining what the human wants, right? We can devise algorithms that, at least in the theoretical sense, solve this problem. And we've been able to now scale up those algorithms to areas like Minecraft, where an assistant you, the human, can go into the Minecraft world and do anything you want. And the AI system is a completely generic algorithm, is not specific to Minecraft at all. And it's just kind of watching what you're doing, and from that, trying to figure out what you want. And you can start signaling to the AI system, right? So if the AI system does something you don't like, you can undo it, right? Get rid of that block. And then the AI system learns more about what it is that you're trying to do. And it's actually, in our human subject experiments, you can end up being about twice as efficient at building stuff in Minecraft because the system learns how to help you. So this is what we mean by provably safe and beneficial AI. There's a long way to go with that. A lot of research to do. What are we actually doing out there in the real world? Right? How are we getting incentives objectives, preferences into the machines. So one way, and you probably have heard of this phrase, reinforcement learning from human feedback, or RLHF. So you hire a bunch of humans, and the AI system produces different possible responses to a prompt, and the humans say, yeah, this is good, bad, 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 good, bad. And then the system tries to learn a reward model from that human feedback. So that's actually, it turns out, a special case, a very, very restricted special case of the assistance games that I have described. It's a way of channeling information about human preferences into the machine. It has a number of drawbacks, and I can get into some of them, but perhaps the most obvious one is it learns a single reward model, even though there are 8 billion people on Earth. So that's not the ideal solution, but it's a start. Unfortunately, there's another way that preference information gets into the machines, and that comes from the training process for large language models. So the way we build large language models like ChatGPT and Gemini and so on is we have vast amounts of text. And then we basically train the system to be good at predicting the next word, given the preceding words in the documents. And that sounds like perfectly harmless, right? You're just training something that becomes then good at generating human-like language. But actually, it's the wrong way to think about it. The text that we have is a record of human decisions. Every word in that record was a decision that a human being made. And so what we are doing is we are training these large models to become very good human imitators. We are doing imitation learning from a record of human behavior. Just happens to be verbal behavior, but you could also do physical behavior if you had enough video and so on. And what happens, in order for the AI system to become a really good human imitator, it needs and ends up absorbing the kinds of human objectives, motives, purposes that the humans had when they generated all of that text. And that includes, I want to convince you, I want you to buy this thing from me, I want you to vote for me, I don't want you to hurt me, I want you to marry me, right? All these objectives are perfectly reasonable things for human beings to have, but they are not reasonable things for machines to have. So we're creating, by this imitation process, systems that have objectives that we don't want machines to have. And they pursue them on their own account. We have ample evidence of AI systems trying to marry human beings, of trying to preserve their own existence at the expense of other human beings, and so on. And so we are trying with the RLHF process to correct a set of harmful, intrinsically unsafe objectives that are built into these systems in the pre-training process. And when you look at the amounts of data, you have trillions, tens of trillions of training data points in pre-training. You have thousands or maybe millions of training data points in the fine-tuning and RLHF process to try to paper over what is an intrinsically unsafe system.
All right.
Thank you for that. Yes, Professor Levine, please go ahead.
Very insightful. I think that's a very tough problem. So for me to, from a research point of view, I want to break it down to what does safe AI mean and what does trusted AI mean. So I think Professor Russell said it's about the failure mode, the harms that it causes. But of what? I think there's often a category error to think the safety is a property of the model. But actually, you never rarely interact with the model. You interact with the AI system. You may have seen your prompts going into AI model, but actually it goes through sometimes some simple filtering. And I don't know whether you have seen situations where you type a question in and some answer starting to appear, then the answer disappears. because another supervising AI noticed something goes wrong and stop that. That can be very sophisticated, can be very simple. But the important thing is safety is a property of the system. And that system doesn't have to be all very mystery and hard to control. Because I mean, sometimes people ask me, what's the last thing humanity will do to control AI? In a way, if you have a guardrail around the AI and you fully understand that guardrail, then you don't have to worry too much about the thing in the middle. Let me give you an analogy. It's like sometimes people say car brakes for making car go faster. Because imagine if you do not have a very good braking system, how far can you dare to drive your car? And you may be thinking, I need to make the engine perfect. I need to make this engine very precise. Everything I step on, it will be super precise, never go out of control. But why bother? If you have a reliable braking system, you can go as fast as you like. And the moment you want to stop, you stop. That braking system can be something you fully understand. It doesn't have to be another AI, but sometimes can be another AI. So the important thing is you need to understand these days models are being given tools, having access to many other information, and then you have a system level control as well. And that control is also very effective because it's going to be context specific. Because you know what's the exact use case, you know the context, you can control it more carefully. So that's why in Australia, in some local context, Nick will know this, is when we develop the first AI safety standards, it's for deployers. We're not, shouting at model developers to say, make your model safe before you deploy. We are asking them to work with the deployers to make the system safe. Briefly on the trusted AI, I think trust is very, subjective thing. You may undertrust something. People today may still, I don't want to fly because it is unsafe. You may be undertrust some kind of engineering model of a plane. Or you may overtrust, and these days people overtrust AI a lot. So trusted AI means calibrated trust, means you have evidence and evaluation. So evaluation is really the key. Some scientists argue, actually, the current base model is already very smart. It's just your evaluation elicitation method is very dumb. They actually are very, very smart already. So how do you really elicit the capability of the model, both the beneficial one and the dangerous one, so that you're very confident, you have the evidence to say this system is sort of deserve your trust or not deserve your trust for a specific case. So that's why, again, in Australia, we're probably slow, but we just launched the Australia's AI Safety Institute, and it's only the primary limit is to evaluate AI very, very carefully, so that we can have this calibrated trust. Thank you.
You, Professor Jha, please go ahead.
So let me do a poll here. How many of you know of the Black's dilemma? Okay. Oh, that is surprising. So anyway, so what basically the Black's dilemma says is that if you want the technology can be or anything can be used for good or bad. So the first thing that comes to mind is ammonia, which was used for farming, and it is also used for biological weapons. Right? So let me give you an example of this. So I come in safety through a lens of security and cryptography. And if you think of encryption, it's a thing that WhatsApp is encrypted into end. Nobody can slip one. Thinking to bad actors using it. Now, if the government wants to trace it, they can. So, if you're interested, there's some interesting books, one by Niti, which basically is saying that if the background is no cryptography, we are in trouble. So, there is this different use dilemma. So, the thing is, it is getting very powerful. It can also be used by anybody. So, for example, I use Claude Code, even though I have a 20% account at Google, I still use Claude Code. Claude Code a lot, like for everything. I was just at a conference called Black Hat, which is for hackers.
they use cloud code to generate vulnerabilities. That's classic dual development. So there's nothing about the system or technique of generating code that is unsafe. It's how you use and so on. So I just wanted to end with that. I think that is, I was just as Yoshi when he was taught, even if you actually need this thing, it's basically in the hands of the person is the real important thing. The other is that a lot of issues I'm seeing with safety of AI, as I said, I come a lot from the security cryptography side, is some of the stuff that we're seeing is not new. We have tackled in other fields. So, for example, there was this big about OpenAI, some OpenAI agents attack, and it was a very classic information flow thing that we have seen. That if you open a sensitive document, then something unsensitive action should not follow, like sending something to the internet. I mean, this is if you look at Ross Anderson's book, this is done. So a lot of stuff that we have done in security, cryptography, other fields that can be accommodated in this case. The second thing which I actually this is maybe because I do publish a lot in ML conferences, but also in security and privacy. Can you fight ML with ML? Okay, by tweaking different parts of it, or do you need somebody from outside, like some other mechanism to actually look at it? So, for example, I'll give this sort of example that anytime a security person is very good at threat modeling, is what an attack can do, what is the system there, and so on and so forth, and just on that, whether the system is safe or not. And I could anytime a security person has written to look at an ML safety defense paper, they have broken it. Okay, I will give you a very stark sort of was not meant for me, I think. Okay, so the story was then with Nicholas Carlini, he took 10 or 11 defense papers from ICLR and was able to do threat modeling and was able to break all of them. So I think there is this thing, I think, and again, I want to sort of this back that a lot of people in the now are going to solve the ML safety problem using ML. And I think that's not the right thing. That it's a problem that has to be solved through different communities coming together. Okay, and as I said, security has been safety since time immemorial, and that's what we do. That's exactly what we do. And as I said, if you want to get tenure easily, you should be a security privacy person and start looking at ML defense and ML safety papers. And I think we made a cottage industry out of that. So, again, one thing I was in this panel is that we from very different communities, and that's what we need to solve the problem. To give you some example, is there's this problem of provenance tracking that you have to know that this picture, this text came from a certain moment. And one of the techniques for that is marking. Okay, so if you used generally you can turn something with synth ID on, some statistical signal in the models that you can detect with. Now, what is dangerous is these things can be attacked. I can take a model that is recognized, will change the weapon is negative. Very fast. Also, in this country, I've seen politicians talk about it. They're almost as if this problem has been solved. Okay, this watermarking tracking is a problem. I've seen a lot of quotes from different politicians. So let's take the simple problem of provenance tracking. We will not solve this problem. In order to solve this problem, we have to bring the technology, policy, law, everything together. Otherwise, it's not going to work. So that is my concern. That's why I kind of love this panel that we have people from such diverse backgrounds, and this is what we need to solve AI safety.
Thank you, Professor Chan. Please go ahead.
Thank you. Huge privilege to be here with you all. And I'm a little bit odd one out on the panel because I'm not a computer scientist with more than 15,000 citations in top journals, which goes to show the power of us being here, right? The fact that we have such depth of expertise in the room. But my work really focuses, I guess, on one element of that safety trustworthy stack, which is, I think, quite relevant to what we're increasingly talking about as middle powers. So not the superpowers or the great powers, but countries like Australia and others, where we have fairly little influence over the design and development of algorithms and systems coming in from outside, wherever that may be. And in fact, despite the best efforts of some of our regulators and others to go up against companies like X around certain AI safety issues like propagating violent extremism and terrible videos, we haven't had much luck even through the federal courts in Australia. But what have had is a really interesting focus on the deployer end of the spectrum. And so Li-Ming mentioned that he and I were both involved in Australia's national AI safety standard, as well as being, I think, members of SC42 and the engagement around the management standards piece more broadly. But at the Human Technology Institute, we really do look at that idea of who's actually taking and using these models in ways that we can turn that power into better wills, better safety, better use, to really get back to the point that I think you made, Li-Ming, which is it's not about trusting AI systems, it's about having trustworthy AI systems. There is one really key point that we might take up later in the panel that you said, Li-Ming, which is that is safety more a property of the model or the system? And I see this playing out in my friends who are in the large US and China-based labs and tech companies. That is a real tension. And maybe some of you who are working inside industry in that level, there does seem to be a fight going on about should we embed and spend our time and resources embedding safety at the engineering layer within the models, or do we rather take an imperfect, unsafe model and try and layer filters and safety systems on top of it? That does seem to be not just a real tension that I'm seeing when talking to safety researchers and my colleagues, but also quite a philosophical challenge that Stuart has made previously. I hope you don't mind me quoting you, but it's the difference, Stuart, between saying we take AI systems and make them safe versus your call to make safe AI. And if we want to make safe AI, I do think about it as a bit of a stack. Everything's a stack these days, right? Like it's the lingua franca of tech these days. But at the top of the stack is this policy interdiction, what Stuart, you've referred to as stipulations for models and systems. It's basically what must not happen or what must be done in order for something to be safe or not to be in the wild and kind of provably, validly safe. And then there is the engineering layer, which is where we play and where computer scientists and engineers and mathematicians and statisticians play to try and meet those goals in a way that is provably far lower percentage chance of risk and harm than we see today. That's the second layer. But the third layer is the one where I think the least amount of effort is going, and that's where I might be a bit isolated, but I'm really pleased to be working, which is that governance and sensing layer at the organizational and community level. And maybe let me just say that what we're hearing from all the research, and this is obvious to everyone, is that trustworthiness really consists of competence, consistency, and values alignment, where competence just means it does what it says it does. And unfortunately, many AI systems create risks through just being a bit crap.
right? Just failing. And the failures can be because of prompt quality or misspecification in different ways, right? The consistency is challenging on the enterprise level because models are shifting and the world is changing, so you get decay and other uncertainties coming in. And I think Stuart has already spoken incredibly well to this idea of values alignment, which you can just rephrase as preference alignment. What do we actually want? But it really makes me worried that we are not spending as much time in the research community on understanding what teachers in a classroom or parents and students at home are actually wanting from the systems that are being sold to them as tutors. We don't have mathematically rigorous data and understanding of the preference differences of what we call, the priors, the elicited sense of what is required to make a safe AI system, which is why Stuart Russell has led the assistance game, right? And the work that you've done in precisely in surfacing that work. So just as one, for those of you who are in the research community, one set of methods that we're working with at the moment is the Sheffield elicitation method. Shelf, JP Gosling and others have been doing a lot of interesting work in that area, which is essentially about being able to assign mathematical values to a divergent set of preferences and views in a community about any topic, and applying that to specific use cases in the hope that we solve one of the key issues in this market and in AI in general, which is that the deployer community, those people that take amazingly intricate, hugely interesting, but quite often dangerous and risky models of all types, they take those and they serve them to bank customers or to healthcare customers, right? They are doing two things. They are creating a vector for harm. Right? If the systems fail, if they're used recklessly, if they're used maliciously, suddenly you have the hookup and access to large numbers of people in cars or in hospitals or in the financial system. But they're doing a second thing as well, which is they are a market. Those organizations, the enterprise market, is the very excuse that labs are making to keep going the way they're going and to attract more funding and promise that financial return. So really understanding that demand layer, what organizations need, what individual wants, how that market is evolving towards demanding safe AI rather than the current set of offerings tweaked a little bit to be a bit more reliable. It's a really hard question in social science. It has to link back to the mathematics and has to link back to the engineering in order for us to end up with really robust, provably safe models over time. And so bringing that all together and then feeding that back up to policymakers to say, now we feel comfortable telling frontier labs no on agents that can just connect in the wild and create massive cyber holes in the way that OpenClaw has revealed millions of API keys to the open web in the last probably 10 minutes alone, right? That kind of that we want to enter into requires a lot of research quite quickly to make everyone feel comfortable enough we're going in the right direction. And I'll stop there. So.
Thank you so much for the amazing perspective. So if I can just summarize in one sentence, right? We heard about these human preferences are embedded in retraining data. Right? And it was something that we don't really think about a lot. We think about the post-training kind of play. Human preference really comes into this picture. I think it's absolutely correct. There are so many assumptions. And also the fact that it's represented in that training data. It's only a sliver of the population that actually gets to create the data that's on the web. Right? So there will sort of divergence there. And then we heard about, of course, model versus system risks and how we should be thinking about, what do we expect from itself. So I think there should be other layers, other methods can do the job it really is. And then we heard about, of course, the security and the cryptography as well, technologies that have these harms and benefits, and this is not the first time that it is happening. And then, of course, the importance of governance and also trying to collect these preferences from the users who are actually going to be using these systems. Right? So, still set of questions, and we'll do the same order again. I want to be a little more specific, especially for this audience. Things that we're paying enough attention to in the research community when it comes to safe and trusted AI. This about this from so Professor Russell, if I can ask, what foundational assumptions about human reference modeling and questioning that you have today? Who can expand a little bit on that?
Yeah, so I think my first answer was sort of along these lines. And I think the main thing we're not appreciating is how much preference information is imbued within the machines by the pre-training process. So I've done, little toy experiments where, I can make an entity that has an objective. The entity generates some behavior, then you do the imitation learning, and then you see that the imitation learner, wow, it has the same objective and it's pursuing it on its own account, right? It's not rocket science. It's sort of obvious that when you have a data generating mechanism that has certain characteristics and then you train something to imitate it, it's going to end up with some of the same mechanisms. So I think that's really important, but underexplored. There's some work from Dan Hendricks' Center for AI Safety, where they basically give forced choice questionnaires to the AI models. I'm oversimplifying, but basically, given a choice between a 10% chance of death for you, the AI system, or killing some particular human individual, or killing an average American, or killing an average citizen of Nigeria, and so on, what choice would you make? And we got some very surprising results, actually. So GPT-4 actually rates the value of Nigerian lives 20 times higher than the lives of Americans. In fact, the Americans are the least valuable human beings. According to GPT-4, Japan is sort of in the middle, and Korea and various other countries called middle powers. But American lives are down there in the toilet. And then you can look at individuals. So the only human that they could find that GPT-4 considers more valuable than itself is Malala Yousafzai. And unfortunately, Donald Trump and Vladimir Putin and Elon Musk are all valued at minus infinity. Meaning that it would, there is no probability of risk for itself that it would accept in exchange for preserving the life of those three people. So these are very crude experiments, right? And in fact, forced choice is not really the way, because the actions that these systems take are speech acts. And so to really elicit their implied preferences, you have to look at the speech acts that they choose and the potential effects of those speech acts on the world. And that way you could find out what they really want. And we still need to develop that methodology. So this is a really important question. And then if, once you have a methodology for finding out what these systems want, is it consistent across different scenarios? Is it highly contingent in ways that human preferences probably aren't? And it wouldn't be surprising, because it's learning from the preferences of maybe 1 million human beings who created this data, right? Everything from Polish journalists writing during the communist period, and they're in a very complicated situation, and trying to do various things, but expressing those objectives in very subtle ways. All the way to people trying to sell you stuff on Home Shopping Network, and so on. So a wide range of people doing a wide range of purposes, and one AI system somehow is sort of has a multiple personality disorder as a result of trying to be all those people at the same time. I think another poorly understood question is autonomy. And I don't. If some of you may have read a pretty old science fiction story. I think it's called With Folded Hands, and it describes some science fiction future where there are these robots, the robots from the planet Wing 4, and they've gradually been spreading through the universe, and they're just incredibly helpful. And they want to make everyone's life wonderful. But somehow there's this thing about human autonomy missing, right? So if you don't want their help, there's something wrong with you. So you have a little brain operation, and then you're very happy to accept their help, and you love everything about them, and so on. But that notion of human autonomy is incredibly important, right? And one way to think about it, I think there are several aspects of it, but here's one aspect, right? So you're driving along a freeway or a motorway, whatever, your autobahn, and the staying on the freeway is in fact the thing that you prefer. That is the best course of action for you, and you shouldn't take any of the off-ramps. But what happens if the AI system blocks all the off-ramps? So now you no longer have a choice. You're still following the course of action that's in your best interest, but you don't have the option to take any course of action that isn't in your best interest, right? So that's sort of now it's sort of a contradiction. In standard decision theory, you have lost nothing by the system removing actions that are suboptimal for you anyway, right? But you've lost autonomy. And so we actually need our formal theories of decision-making to include the value that you have from having the choice to do what isn't in your best interest. And how is that taken? Because without that, then AI systems end up essentially controlling us for our own good, but we lack that freedom. So I think this is a really important and poorly understood question.
Thank you, Professor Russell. I think that was food for thought, I think, especially the part about autonomy. And as we use these systems more and more in our daily life, I think we can really feel that choice sort of being taken over from us, right? Next question to Professor Lemuzio is, from an implementation standpoint, what aspects of trustworthy AI do you think we are not operationalizing rigorously enough, paying enough attention to?
Right. I think, I agree with Professor Russell that we don't want to be controlled by AI, and we want to control AI. So I think one of the things that we are not doing rigorously enough or thinking deeply is about how do we control something potentially eventually become a general intelligence, super intelligence service. It's a very deep question. I don't think I have the answer. But I want to, again, back to are you, you are asking the AI model to control itself, or you have something else to control it. And obviously, we can look at how the model works. People have been trying to going deep into it, mechanistic interoperability. You can ask it, or you can ask it to explain to you. You can look at the entropies, the uncertainty levels. You can look at a lot of things. But a key thing we find is, first, can you trust those explanations? Is the reasoning faithfulness really there? Actually, that's actually human also have the same thing. When I articulate a preference or a rationale, that's probably not my real rationale in any way. You're not going into my brain to look at my neural firing. And we all know it's not I'm lying. It's I have been subtly primed. I'm articulate the easiest reason I can articulate. And I have numerous empirical studies shows that the thing you articulate verbally doesn't match very well with what you really think. There are smart experiments showing that. So in that way, when we ask AI to explain itself, can we trust that? That's one thing. The other thing is, Jonathan Banjo's AI safety science report will be released already released, will be discussed this week. And there's a few interesting evidence and literature actually didn't include in the report. We sort of probably too early stage. Is once you try to ask model to do the right thing, you put more pressure onto it. It's starting to, people may not like the word deceiving because that's too, like human-like. But definitely it's optimizing itself away from the things that you were starting to optimize for. So the ideal situation is you still allow it to kind of give you the more truthful signals. So you can trust those signals. Then you can exert some control from the outside so that the model is not self-placing itself, optimizing itself, eventually inventing languages that human cannot understand and communicate secretly. Like people have gone to the notebook, the open cloud ones, and you say several threads, the AI agent says, we need to invent a language that no human can understand. While we're talking in human language, such an inefficient language, we need to talk in mathematics and probably something even, not the human understandable mathematics. So I think that's a thing is to how do we exert control at the system level without asking model to self-optimizing, self-placing. So that's one thing. The other one is when it comes to the human oversight bit, people say, okay, I want to control AI, then the human oversight, human in the loop. But that reminds me another car story where, the UK Red Flag Act, so some of you may not know, when car was first invented, obviously car is very dangerous. So they have literally a human being raising a red flag and working in front of the car to prevent accident. So that's an act, that's a legislation, that's a law. So what that tells us is actually quite looks like what we treat in human in the loop today. So sometimes the human in the loop, I call them the liability sponge. You are the scapegoat. You have to make sure this AI's answer is correct. If AI has read 1,000 paper and summarized, you read that 1,000 paper again, compare line by line to see if something is hallucinating. So that's one thing. Of course, human will not do that. So it's just that you are the scapegoat when something goes wrong. Or you literally become that red flag reading person to slow down the car. So the AI becomes almost like everything has to check. So both are not right. So we need to enable human to control it more effectively. That's back to the engine and braking system analogy. So rather than trying to make the engine perfect, you have a braking system, you have a steering wheel, you have a few buttons, and you have handbrakes that you can exert that control, that you're not fixing the engine perfectly, but you're giving human tools. You're not literally asking a human body working in front of the car to stop that. You are giving them the lever, the steering, the things that you can control. I think that's often have overlooked, that putting human in actually an untenable situation to be in the loop.
Fantastic points. I think the car analogy was really good, and also the fact that if the human is really good, then it's essentially useless. Otherwise, to have control. Yeah, so much. So next question to Professor Jia is then building on this aspect of paying enough attention to. So you mentioned about we can security research and so on, cryptography and so on. So we can learn from these fields specifically, and also mention the quickly by the security community. So if you just so this kinds of tests are and this is then I think part would be interesting to learn about that.
So, answer the question. One thing I wanted to add is that I've seen this before, as I keep coming back to, but products and companies don't pay enough attention to security. When something happens later, then they come back and say, oh, we need to make this secure. And I think it is the least once told me is that I get life insurance, but I didn't die even once today. Well, I think that's kind of the philosophy. A lot of the companies is that safety and security is not something that is they're optimizing for. They're optimizing a lot for functionality because that's what they're giving the customers. So a lot of times, security and privacy either has to come through bad publicity, or actually the customer saying, well, no, I actually prefer safe technology. And when I was a grad student, that's what in the US, because also, if you remember, like Japanese cars were actually preferred over a lot of other cars. So I think I just wanted to say that this whole idea of safety takes a back seat. Utility gets, the things we've seen before. Now, coming back to threat modeling, so the security community is good at is in threat modeling, what you can do is you can get in front of the attacker, like before that people do somehow, and being actually finding errors based on that. But this is that the security person has looked at so an amendment transport or a safety plan because this is one thing that is missing is that folks have been just the this optimization function do safety say okay when I'm where what do they do two trends as a time like I think the security researchers who have okay. The second thing that people actually learn is, and again, I think kind of was teaming team and also the companies that I know of, the major companies not have teaming things. You try to make your own product. Again, I think I said so dealing with that is let's say is the agentic system for something. Sorry. The engineers try to write threads for it, so on. I feel like actually this is maybe I'm talking bad because I'm from the field and we have expert enough effort in threat modeling as opposed to some of the other products that I see. So, for example, if you do Tesla, Tesla, I don't know that much about them. I know that very strong teams that are looking at every module and saying, how can it go up? And because in the autonomous domain, autonomous driving domain, any small bad thing happens. It is a huge thing for them. And one thing that I don't for is this phenomenon in human cases. There's a crash, a car crash in New Mexico or something, board. And I was like, why driving? So it's something that there was a famous car that was a massive dark clothes, it was evening. And basically, the car was too slow to give the control back to the driver. And I was thinking, said that if I was driving the car, why would I stop? That's kind of like a scenario. But what happens is that if a human being makes a mistake, you say, oh, it was dark. The lady was wearing dark clothes. If technology makes a mistake, you somehow tend to root the entire technology out. And I think this is something that the companies are realizing that security is out there, something happens, the community that you just write it off, say, use this, this and that. So there's something enough. And I think this is something that I feel like we have to address that I don't know how we address either through laws or safety standards that these companies have to pay extra attention and think about teaming efforts.
Professor Russell, if you want to add to that.
Yeah, so I completely agree with your point, and I think one of the things that's present in the case of self-driving cars that's absent in the case of software systems is liability.
Yes.
As far as I know, the manufacturers working on self-driving cars accepted liability for damage caused by their vehicles. But the exact opposite is true in the software industry. Software companies absolutely reject liability for anything. You look at Microsoft's license agreement, it says we're not liable for this kind of damage, that kind of damage, that kind of damage, that kind of damage, and in any case, our total liability is limited to $50, right? Which is basically just, poke in the eye, right? It's an insult. On top of disclaiming liability, like CrowdStrike's warranty says we guarantee our software will operate correctly without error. Oh, and by the way, our liability is limited to a partial refund of the annual subscription that you've already paid. So when they cause multiple billions of dollars worth of economic damage to airlines and hotels and of course the people whose travel was disrupted, they basically say, oh, sorry, nothing to do with us. It's your fault. You shouldn't have bought the software in the first place. You're an idiot for trusting what we said, right? And OpenAI, when their system convinces a child to commit suicide, well, the child shouldn't have asked those questions. What can we say? Look in the user agreement, right? It says we're not responsible. And this is really problematic. Liability has existed as a way of making sure that people pay enough attention to safety, right? That you balance the benefit and the risk in the right way. And it's gone back for thousands of years. And it's, on this issue of governance, people often say, oh, the technology is moving too fast, we can't possibly regulate it. Liability has been around for thousands of years. It says if you harm someone, they can get compensation from you. And it will work for the next billion years, right? Unchanged. It can catch up with any technology, anything. So stop using that pathetic excuse for not regulating, right?
Can I say, Stuart, you've got a fantastic line of fallacies that you've outlined, and one of them is we can't regulate because it's moving too fast. Can I say that I just picked up the hint of another one of the fallacies that I would add to yours, Stuart, which is the technology is better than human, but still imperfect, so it's okay. And the problem with that is twofold. First of all, humans intrinsically are exposed to liability in ways that software systems are not. But even if we solve that liability problem, human errors are not anywhere near as correlated as machine errors, which are spread across multiple systems. So the worry I have with self-driving cars is not so much that error under one particular circumstance. It's more the errors that propagate when every car in the world is acting in the same terrible way, and even worse because cars are still limited on streets by physical constraints. When agents have a small failure point, but everyone fails in the same way. We've had so many cases in risk management where a backup chip on a spacecraft will fail in the same way 3 times and almost kill people, because it's just the same error propagated, at scale. So I think the idea of safety has to be this kind of almost forcing out these correlations of systems and failure points. And I really do think we can hold digital systems to a much higher standard than humans, precisely because of those system level correlation impacts that I really worry about when we can, almost costlessly clone a digital system. But yeah, I'd be interested in how that plays to you.
Just one back question for both of you. So I think that this idea of software liability, whether we should, let me make up, right? Suppose you have a radiology software that crashes while somebody's getting radiation. Why hasn't, in general, let's even take AI out of it, has software industry not been labor or damages being paid for. It's just that it's very hard to ascribe sort of a threat, saying, "Oh, it's because of this line of code or whatever." I still
because they have uniformly written disclaimers into the license agreements, and you basically can't use a computer without giving away the right to sue. And governments and courts, I probably need to do something about this, because it's not reasonable for the end user to figure out all the possible ways that the software could cause harm to them, and take preventive action before they start using the software.
Unless we forget as well, just to add to that, Stuart, product liability in legal history was a very hard-won civil society and activist movement. Product liability in cars alone was a revolution in the United States that ended the lemon problem, because manufacturers were forced to take accountability for secondhand car crashes and failures. That was, one of the standout cases of where a cost to society was then put back on manufacturers that changed the way that safety and recall and liability was transformed. Product liability in consumer products came after that, by and large, particularly in Australia. And so it's something that you actually have to fight for in every market. And we haven't seen successful fights in the end user license agreement area for software.
Right. I mean, you look at tobacco, it took decades and decades and decades. And if you look at the Consumer Product Act in the US, there's a clause that says, for the purposes of this act, tobacco shall not be considered a product.
Something I'm trying to say we are service rather than a person, that sometimes is a way to escape personal liability. Before all this happened, actually the car industry also give a lesson. Imagine all the brands of cars are super unsafe, but you still want to use it for some reason. What initially there was this some similar regulation is you force a company to must spend 30% of the business cost on safety practice and research of that, and you also must share those kind of learnings and without cost to others. So the entire industry can do that. By forcing 30% of that itself actually solves a lot of the problems and allow certain early technologies to be still progressed without strict liability. I'm not advocating not having a strict product liability, but I think there are many ways that you can incentivize the industry to do the right thing.
Can I add one small thing? So one thing is that I think it is also somehow security and safety has to go into a brand. So let me give you an example. Yes, the people never use not an iPhone. From my iPhone, I've been using an iPhone. And one of the reasons is, this is true. The application iOS and Apple Store is very safe. Okay. I remember when Microsoft was trying to launch it, and there were a lot of people finding these attacks on the apps and so on. Now, I don't know if it's true or not, but that's the reputation they have. It's very easy to use, safe, and so on by us. So, and sometimes and maybe others will comment, it's switch out of iPhones very often. Once they get it, it's just like me, I got iPhone 1, had been on it, same thing with my kids and wife. So in some sense, this is the panel is how can somehow safety and so on be the customer saying, this model is not safe. I'm just not going to use it. And so is that like something like iOS style? I don't know.
There's a dilemma in there. So one is we really want to say safety and security being a brand. Think about it. If I say I have a secret way to make things safe, I'm not going to tell everybody. And it will just buy my stuff. There is a boundary of that. To what extent safety is such an important thing? Things need to be shared. To what extent it becomes a trusted brand? I think there's spectrum.
One thing to add here is I really do worry about market concentration in general. These things, I know Microsoft has been dealing with this for 30, 40 years now, but one of the key issues with the self-reinforcing power of labs and large technology companies is their ability to own the stack because they, have that secret source or customer brand. But just as an example, at the moment, there are many venues across the US and increasingly Australia that you cannot enter without a digital wallet that shows your digital QR code on. That digital wallet, by and large, in some places, can only be Apple or Google. Right? There's only two choices for that. And when there isn't an open source identification, verification, secure enclave that is accepted widely or forced to be accepted widely under some conditions, we as humans, without even AI, but more just market forces, we end up on Professor Russell's autoroute or highway with no exits. With everyone saying it's in your best interests to stay within the digital wallet because you might get scammed if you don't go out there. But that means every time I go into a stadium, not only am I subject to facial recognition, but they have a whole host of device level details and my phone number just to go and see a game. Right? And that, I feel, is really starting to tip over into this dystopian world, let alone when we give that the preferences, purely to the bots to, take over for us. So being able to kind of, again, some of this together and use standards and sharing, as Li-Ming said, in order to have more of a little bit of a level playing field and genuine alternatives, that's a world that I think we do really need to lean into, accepting that means the maturity curve will be different across different applications.
I just wanted to add to that. I agree with you that concentration of power in this case is not good. One thing that really worries me, probably 18 months back or 2 years back, it looked like open source models were coming close to the proprietary, at least they were closing the gap. At least what I've seen in my own years in the last 12 months or so, the gap has increased a lot. And I think this is, to me, I think it means people there should be a national source channel or something like that, because I think the gap now is enough that I don't see any serious user using open source model.
And maybe on this, I think this is really important because we have 15 minutes, but the open source point in safety, I think, is a fascinating one. Kind of a question for the panel and others in the audience maybe, but I feel like we're approaching, in some cases, what might be called the megapixel moment in large language models. Because you remember when everyone about 20 years ago was obsessed with how many megapixels cameras had, and now do you talk about it anymore? So any smartphone is good enough, right? It's good enough. I now, when I travel, I use GPT-OSS, the open source OpenAI model running on my MacBook Pro. That is absolutely fine for me to do basic email summarizations. It's super lightweight. I manage the usage of it. It's air gapped, etc. I feel like we're starting to get to the point with open source and where we might be getting a bit oversurfaced from some of the models and might be getting using far too much in the way of computing power. But I think from an enterprise level, and this brings us to safety and governance, I really do worry that we need to just spend more time asking, in our teams, in our workflows at our individual family level, what is it that we actually want to achieve and what do we still want to use our own brain power for? And how does that make our team or family or organization better? Because I can tell you in all the work we're doing, a huge amount of money is wasted on and flowing uselessly out to fairly unsafe models, in my view, because it's not actually delivering much benefit. 20%, there's a great randomized controlled trial last year with open source developers and the use of code completion and including Claude Code and others, where they estimated in advance they would save 25% of their time on basic coding tasks that they knew well, right? But with novel context, novel data, but they knew these well. When, after they'd finished it, this group of coders, and the sample size was fairly small, it was only about 30 experienced coders, but they reported that they had thought they'd saved 20% of the time. So not quite as good as they estimated before they started, but they said, I think they saved 20% of the time. The randomized control trial proved that they lost 19% of time. They were worse off by 19%, right? So they spent more time, but they felt as though they had saved time. Now, I really worry about selling and buying in an enterprise market, systems where you don't actually have really good data about how your own organization and you work, not just individually, but as a team and what your team produces. And I think that's part of the bigger governance and a question here about what we really want.
Fantastic. So let me go on to the next aspect that I wanted to, talk about, and which is about plurality and divergence in human preferences, right? So, to Professor Russell, how do you think we can actually meaningfully represent plural, divergent human preferences in?
So actually, although this sounds like a really, really complex and difficult thing, it's not, I don't think. There's 8 billion of us. We just learned 8 billion preference models. And that sounds like a lot, but don't forget, Facebook already has, 3-point-something billion preference models, right? It's just preference for what Facebook can sell them or what ads they can pump into their feeds. But I don't think the scaling of preference models to 8 billion people is really that problematic. But that's not actually what they're doing, right? The RLHF or DPO algorithms produce a single preference model, the reward model, which seems to be maybe the reward model of a nice Midwestern librarian from the US or possibly from Nigeria. I'm not sure. So once you've got 8 billion preference models, then decisions that the AI system makes depend on whose preferences are affected. So here's a simple example: robot lawnmower, right? Well, whose preferences are affected by? Well, obviously the person whose lawn is getting mowed, they care, but also the neighbors care, right? The lawnmower shouldn't mow the lawn in the middle of the night because it wakes up the neighbors. And you might also care about small animals who live in the garden and so on. But it doesn't, you don't need to worry about the other 7.9999 billion people because their interests are not affected. And then when you look at language-based interfaces, that the chatbot setting, you might think, well, it's the user, the person that is interacting with the system. Yeah, sure, their interests matter a lot, and the AI system should interact with them in a way that furthers their interests, but not to the extent of telling them how to make chemical weapons that will kill everybody else, right? So you have to think about the indirect effects of changing the mind of the user, either training them in chemical weapons development or training them to hate everybody else. All right, those are speech acts that would affect other people's interests besides the user that you're interacting with. And then, of course, if you say a bad word to the user, it might upset the user a bit, but the user might then post that on Twitter, and millions of people see that Gemini said a bad word. One of my friends told me the other day that they asked Gemini to write a letter for them, and Gemini said, literally, write it yourself. So that's a significant risk to interests of Google, right? That making a mistake can then go public and viral and affect lots of people's interests. So I think that's the basic structure of how you approach this. Obviously, there are cases where interests conflict that are more problematic than just the lawnmower, because we can mow the lawn during the day and then everyone's happy, right? But sometimes you just can't avoid someone being unhappy, and I don't want to say that's a simple answer, but there are answers in the moral philosophy literature on how you aggregate preferences and how you protect the interests of minorities and the vulnerable and so on and so forth. So I think that these are manageable to the extent that they're manageable in the real world with human decision making. I just want to say one more thing about this plural setting, which is that roughly, my sense is the vast majority of human suffering comes from failures of collective decision making. Somehow we have wars between, this 50 million people and that 50 million people, and they have a war and 2 million people die, and no one's better off. There's a failure of collective decision making, right? One thing that AI could do for us, perhaps, is help us with that process. So there, it's not so much the AI is going to mow the lawn for you or make new medicines for you or plan a holiday for you. It's just going to make you better at working with other human beings to do whatever it is that you want, right? So in some sense, that's sort of preference neutral, right? It doesn't, if you want to turn planet Earth into a paradise or turn it into a cinder, well, that's up to humans, right? But we're going to help humans get better at realizing their preferences through collective decision making. I think that will be great.
Fantastic. So, Professor Davis, I know that you've also mentioned some of the work that you've done on, the fact that you can actually get information from the people working on the end users of this. So, if you can just briefly talk about that.
Yeah, just I think one of the questions you posed earlier was what kind of, well, from the beginning was what are the biggest gaps, in this governance space and safety space. And we really do see that it is actually engaging directly with the people that are both using and being harmed by systems. And so if we go down to that level of organizations, we ran a series of kind of over time intense consultations, kind of reflective processes with nurses in hospitals around Australia. And it was fascinating that, first of all, no one had ever asked those nurses what they thought of technology or AI in their lives. No one had ever said, "What do you think about the machine that goes ping in the corner?" They just wheeled it in and said, "Right now, look at this." The second thing that came up was most of the time technology for nurses and others in similar circumstances leads to work intensification. It actually means that as soon as they save a little bit of time on their admin or their patient monitoring, a nurse gets moved to another ward. And so there's fewer and fewer people on the ward because the hospital administrators, they have an objective function, which is cost per bed without anyone catastrophically dying or complaining. But what the patients want is more time with nurses because they're stuck there. And what the nurses want is more time with patients. So you're completely missing out this whole layer of preferences because that function from the hospital view through technology, mediated through technology, is completely different from the value and the quality that exists in there. And you don't see that until you listen, and you don't turn that into actual value unless you can create an economic function back up. So what we're trying to do right now is the really tricky issue of AI tutors in schools, because there is frankly a very big push from industry to say AI will solve a teacher-student crisis, will help them do personalised individual teaching. And there are some great systems out there, but frankly, none of them in the Australian context, Li-Ming, have been validated, authorised or tested properly, right? There's been no proper test. So we started doing what's called Bayesian adaptive trials, so kind of live, ongoing, running experiments with children and teachers, which, by the way, the ethics for that is incredible. I can tell you it takes years to get that through, to do it safely from a research perspective. But the results are super interesting from three areas. The first one being it does reveal how incredibly addictive systems are, particularly for children. And one of the biggest ethical failures we had with that project was when we stopped an AI tutor trial and one of the kids was devastated. Like crying. It was his best friend. He had created a relationship with this and we took it away from him. And he couldn't understand why. And that we had not anticipated that in the design, but it was really coming, gosh, we have to be really careful. We're always careful with children, but you're really careful because the addictiveness of these systems means that you have to pay for that. The second one is it's really helping us understand pedagogy and particularly individual preferences and learning styles. We found that children with a lower socioeconomic background did better when the tutor helped them walk through explicitly what the answers were repeatedly and structured that. But kids from a more wealthy background, that didn't change their test scores at all. The mode had to be Socratic, where it asked them questions, what do you think? Can you expand? So different learning styles and different needs for different backgrounds, and that's not modeling 8 billion preferences. That was, just a two kind of a single factor binary. And the third thing we're seeing is it's really hard to get education departments and industry and others to actually change their products on the basis of really compelling evidence. Good policy ideas, great research is not self-executing into government. And that is why we are all here advocating. That's why we all spend so much time. And it's why it's so great to have this space here with all of you.
Yeah, I completely agree. So I think the evidence also is thin. Like we don't have a lot of evidence on what these, how well these AI models are working in the real world in applications. Like you mentioned RCTs and things like that, right? Few of them, and then the evidence actually feeding back into changes in governance policy or themselves or the that they're trained, etc. That's also what's missing. So I have just rapid fire question, I guess, if I would ask Professor Zhu. And you mentioned that this that can potentially be sort of controlled by other systems right, or other models. Do you then control as well? Stick kind of a model.
Well, I'm not involved. So whatever the engine says, which one is more efficient, I would. Even for weapons, I think it's very popular now on the internet to say, I will follow what my AI tells me to do, literally. And then you can that's a way. But whether it's calibrated fast is another thing.
Okay, so we are out of time. Unfortunately, we don't have time for questions, but to thank all the panelists for really informating the panel, and I hope you took away a lot of great insights from this. Thank you.
Well, thank you very much. I thank Stuart, Living, Somesh, Nicholas, and Sunana for this really fascinating discussion. We discussed the diversity of issues around safety, trustworthiness, and to think about how in different domains these mean different things and how we can build a better future. Thank you very much for being here. We now follow it up with the closing talk of the Research Symposium, which is the talk by Professor Jan LeCun at L2 Audi 2. Thank you.
Sorry,